Hello all, welcome to my YouTube channel. And today it's again the continuation of decision tree, but today we'll focus on the practical. I know a lot of things we talk about: entropy, Gini index, information gain, pruning, and today we'll just go through those things in a practical way. So let's start, and then I will explain why decision tree is so important, because a lot of the other algorithms uh, like random forest, ADA boost, gradient boosting, XGBoost, everything is depending on decision tree. And one of the most important thing is that decision tree can get overfit, and we'll try to show that, and how the pruning works. We'll try to explain that. Okay, let's start. Again, I'm just loading the inbuilt data sets, which is the breast cancer data sets, and these are the data. I'll just share this notebook so you'll understand. Okay, there is nothing new. So let's just figure out what we are planning to do. So this will be a classification problem, and based on these features, we'll try to check whether the person will have a breast cancer or not. Okay, so 0 and 1 indicator, just a classification problem, and hopefully um, you guys understand up to this. Oops, why am I missing something? Um, no, okay, sorry. Cool. So we have basically 31 columns. Out of that, 30 are my features, and we have only one target column. So up to this, nothing new. If you're following my channel, this is the same data sets I use for all the classification problem, just to make sure that you are following the data properly. No need to change anything. So very simple. Then we are just splitting the data into two parts: independent features and dependent features. And then what I'm doing, I'm splitting the data into train and test. Next, what is important for decision tree classifier, because right now I'm showing a classification problem, so use the decision tree classifier. And what I initially do, actually, I will just pull the decision tree classifier without anything. Okay, let's do one thing. Always remember, shift tab is the best option for you. Once you do a shift tab, you will get this chart, and just follow a little bit. What is the default parameters are here? So right now the default parameter is Gini impurity or Gini index. Again, I explained in my class, Gini from the performance point of view faster, because there is no logarithm of calculation. Entropy has the logarithmic calculation. So be mindful when you select this and do the hyperparameter tuning. Right now, I'm not showing the grid search CV hyperparameter tuning. My main focus is to show is the post pruning, and next class I will show you the pre pruning using the grid search CV and all those things. Okay, these are the default parameters which is used, and so if you have to understand any of this parameter, a lot of informations will be available here. Right now we'll focus on this max depth one. This is the parameter by which we can control the size of the tree or the depth of the tree. Okay, very important. Let's close this. So right now when I'm calling this, I have not mentioned anything, everything is the default. Okay, let's me one thing. I think I should shift tab one more time. What is important, like when we have the max depth equal to none, what does it mean? It's mean the tree will grow as long as it's not finding the leaf nodes, and I'll show you that. Okay, and that will cause the overfitting problem in the data in the training side. Okay, and I think you almost know that what is overfitting, what is underfitting, what is bias, what is variance, all those things. If you are not aware of it, just see my some of the videos, you will able to see it. Otherwise, just email me, we can talk, we can explain, not a problem at all. Okay. So let's see what I'm doing. Basically, I use that decision tree classifier. I'm using my training data sets to fit the model. And there is a very, very good technique by which you can actually draw the complete tree or diagram the complete tree. Okay, so let's run these things. So I think I already ran it, and then I'll draw these things. Okay, so right now I am using max depth equal to none. What will happen actually here? It will create a complete tree, and you see all the trees. Last is actually Guinea is 0 0 and values and 2 0 0 5. So these are all pure split. So everything will continue up to the pure split. Everything, all the places it will continue up to the pure splits, and this will cause the overfitting. Because when the new data will come, that new data might not go and to the complete place, and it will not give you the same kind of accuracy. So that's the problem. And let's see, let's understand. So now suppose we have the test data which we will use for our calculations, and again we will use just the accuracy, because in our case there is not imbalanced data, it's a properly balanced data, so no need to worry, and just will calculate the score, accuracy score. So what is my accuracy score right now? My accuracy score is 0.93. Okay, and I just printed the classification report. This is good informations also, but right now I'm not focusing on this one. Let's just focus on this one. Okay, so what is happening if you allow this thing? Look at the score is 93. But if you do, so now we are talking about the post pruning, right? Which is probably good if you have this kind of a small data sets where you this kind of, if you try to draw or plot the picture, this will be meaningful. Don't do this thing if you have a lot of features, if you have a lot of data. Post pruning is not recommended. We have to do the grid set CV, you have to do the pre prune. Okay, this is more like in-depth intuition. That's why we are doing this post pruning, understanding what is the pruning mean, how the max depth features or any of the such parameters, hyperparameters, actually improving the performance, improving the, helping us to reduce the overfitting and making the model more like low bias and low variance. Okay, so let's understand few things actually. Like if you check this thing first, what it is doing. So number of features. So let me do one quick thing actually. So data, just one shape. Oops, sorry. Okay, 569. After this, extrain. Let me do one more time. Extrain dot shape. Okay. So I have 426 data, and what this will do, look, this 426 samples will be divided into this Y and N, and it will calculate the Gini. If you are not able to properly see these things, I will um, share this notebook, but try to understand. It is taking x equal to 27th column and features, and it's calculate the Gini, and then it calculate the information gain, and it is doing the split. Okay, just by seeing this thing, like if we continue, so this is like a depth 0, depth 1 and depth 2. Just up to this layer, if you come here, probably we have good enough information to do the classification, because we have only 10 records here, which is probably on Y, another is N. So easily we can classify this thing from here itself. We don't need to go in depth of these things, and this is causing the problem. So let's do that thing. Let's do this thing. So what we'll do this time, now we are making a change. What we are checking, making a change? We are bringing max depth, which is one of the hyperparameter, but right now we are just fixing that hyperparameter. Okay, let's fix only for 2 level. So what does it mean? It's mean we'll continue only this level, and probably this level, up to this, only this level. Okay, and let's see how the performance is improving, how this is improving. That's the main thing. Okay, so we are right now doing post pruning, so that's why this is the approach you're following. So we build the decision classifier, we draw the picture. Now look at this. We have only this much. This the tree actually grow only two levels. If you consider this is a 0, this is 1, this is 2, and you have enough information to split the data by 1 and 0, by y and n, like this. Okay, so this is very important to understand. Okay, now let's just do the y test, sklearn, and before I run this, note this thing probably. So this was my previous, so this was my previous result. So before post pruning and after post pruning, my result. So this is my result. So this is after post pruning, and just by only one parameter we changed. So this is after post pruning. And what we did here, we use max depth d peak th equal to 2. So this is the way we do the post pruning, and this always help us to reduce the overfitting conditions and give the better performance. So this is, if you have a smaller data sets, you know the data completely, you have a in-depth, you want to understand the in-depth intuitions, how the model is working and all those things, then this is probably the fantastic way to do the post pruning, and kind of you can explain what you did and everything. Again, in my next video, I will explain how to do the pre-pruning, because when you have a lot of features, lot of data, this kind of visual diagram will be very difficult. So we will rely on grid search CV, and grid search CV will basically give you the best parameters. What is your best max depth? What are the other parameters are the best one for this tree? And it will identify it and you will use that. So I'll show that in the next video. Um, Thank you so much everyone for listening this. Please try to understand, follow my channels. I'm growing, you can also learn, and we can grow together. That's my main goal. Sharing the knowledge can help you, and that will help me also. Thank you so much. Have a nice day. Have a blessed day. See you in the next class. Bye.